So if we look at oxidation in the way that we originally probably learned about it, let's imagine that we have iron reacting with oxygen, and it produces iron oxide. Now, iron is a transition metal, which means that it can actually have more than one form of ion. In other words, it could be iron 2 plus or iron or Fe2 plus or Fe3 plus. So what we'll do is we'll just I'll just make one of them. It doesn't matter, to be honest. The same idea would apply, but let's do Fe2O3. So actually, I can put this in the title. This is iron 3 oxide. It's iron 3 oxide because I need to have, so it's going to be, it's 3 Fe3 plus, and if I have two of those, it balances out with 3 oxide ions. So we end up having a 3 plus and a 6 plus and a 6 minus. And so that's why it's Fe2O3, because we need to have 2 of these and 3 of these in order to balance the charges. Okay, so that's kind of the story behind that formula there. So we can see if we look at the actual, first of all, we know that this is oxidation because the way that we originally think about oxidation is something's reacted with oxygen. Something's reacted with oxygen and has combined. So the iron's been oxidized, which is why it's called iron oxide oxidation. But now we're going to think about it in terms of the electrons, which you mentioned earlier on. I'm going to make these green. I'm going to put these down here. Now I'm going to balance the equation. So we've got 2 ions over here. We've got 1 ion over here. Actually, maybe if I can pause that, maybe I can get one of you to balance the equation. Maybe you can balance it on a piece of paper, and then you can both tell me what you think the answer is. Okay, good. So that's the balanced equation right there. So anyway, the main thing I want to be looking at is the actual electron, what's happening to when we say the ions being oxidized, what we're going to do is we're just going to look at what's happened to the iron within the iron atom, within the equation. So it started off as iron, and then, let's change my color back to blue, and then it became an iron ion. Right? And so how did it become this plus? How did it get this plus 3 charge? Well, because it lost 3 electrons. And so these 3 electrons are written on the right hand side like that to demonstrate that they were within this, and now they've come out of it, so they're separate from it. So we can say the iron has lost 3 electrons. And so from the phrase oil rig, oxidation is loss, reduction is gain, and of course this is of electrons. Then we can see that, so we've got we can see that the iron has been oxidized. So this is now, we saw that iron's been oxidized because of looking at with oxygen, but we can now see it in terms of the electrons. So if we go back to where it was talking about down here, it was talking about a reducing agent. Well, reducing means it's talking about reduction. So something that is going to reduce something else. So this is doing the other way around. This is what happened to get the iron into the iron ore in the first place, it rusted. So let's take another example. We've got this aluminium has reacted with the oxygen, and now is stuck within the. If we just take maybe we can grab our picture of bauxite over here. Yeah. So we've got within bauxite is aluminium oxide. Now, if I get a periodic table, I'm going to pause the video. So, got a periodic table. We're going to make aluminium oxide. Here's aluminium. Here's oxygen. So I'm going to pause the video, and I want you to construct a formula to show the reduction of aluminium oxide to aluminium, and then I also want you to balance it. Okay, so let's have a go at that off video. So good. So the formula ends up being the same. Well, not the same, obviously, but same sort of structure as the previous one, because aluminium is in group 3, oxygen is in group 6, and so aluminium will form an Al3 plus ion. Oxide, we already know, is an O2 minus. So for the same reason as before, we need 2 aluminiums and 3 oxide ions to balance them out. You get a 6 plus and a 6 minus. So now we know the formula for that. We know it's going to produce aluminium and Al and O2. And so the balancing ends up being the same as before, only the opposite way around. So this is a reduction of aluminium, because in here, as we know, it was the aluminium ion Al3 plus, and it became Al. Now, where do we put the electrons now? What we do is we put them on the left-hand side. The mistake that some people make is they put them on the right-hand side and they take them away. But it's not maths, it's chemistry. So this is not a mathematical equation. What I'm writing here is what is there before the equation and what is there after, or what is there before the reaction, or what is there after the reaction. Before the reaction, there is an aluminium ion and there are 3 electrons, and after the reaction, these things have combined to form aluminium, and so that is there after the equation, after the reaction. So this, and as you can see, aluminium has gained the electron, and the reduction is gained from oil rig. So when we talk about the reduction agent, well, in this case, this would be electrolysis. So actually, I just realised this is probably not a great example. So if I instead do go back to my iron oxide, and I'll just do this whole myself. So Fe2O3, I want to get O2 and an Fe, but in order to make that happen, I could use electrolysis and make that reaction happen, but instead what I'm going to do is use displacement. So I could react it with carbon. Now carbon, if we look at the reactivity series, is actually higher than iron in the reactivity series, and so because of that, I can react iron oxide with carbon, and the carbon would displace the iron from the aluminium oxide, and it would take the oxygen for itself. So we won't get that. We would get CO2 plus Fe. So yeah, let's have a go at balancing that now. All right, so well done. This is the balanced equation, isn't it? Yeah, that works. So again, this is reduction. So what is the reduction agent? This is the reduction agent, or the reducing agent, because this is the thing that enabled the iron to be reduced. Okay. So pretty rubbish example I did earlier on, actually, because there's nothing actually reducing the aluminium, because when you do extract aluminium, because aluminium is quite reactive, we actually use electrolysis usually to extract aluminium. We could use something more reactive. Well, we could use electrolysis, to extract iron, but we don't need to because carbon is fairly easy to come about. You can also use carbon monoxide to extract this as well, and that'll be a different equation. Anyway, we'll leave it there, and I'll just stop that video.